Hello everyone, myself Vempali Lavanya from MSc Ed Physics 12th semester from RI Mysore. In this video, we are going to discuss about applications of nanostructured polymers in fuel cells. Coming to the topics that we are going to discuss in this video are what are nanostructured polymers, its types, and what are fuel cells, and applications of nanostructured polymers in fuel cells. And at last, we are going to discuss about advantages and limitations of nanostructured polymers. What are nanostructured polymers? Nanostructured polymers are polymeric materials whose internal structure is controlled at the nanometer scale, that is about 1 to 100 nanometers. At this scale, polymers show unique mechanical, electrical, optical and chemical properties that are very different from the ordinary polymers. And coming to some key features of these nanostructured polymers are they have extremely high surface to volume ratio, they have improved strength and toughness, and also enhanced thermal and electrical conductivity. Tunable optical and barrier properties will be there so that we can mold according to our need. And these nanostructured polymers are also lightweight and flexible. Now, let's discuss some types of nanostructured polymers. First one is polymer composites. Polymer nanocomposites are the materials where nanoparticles are uniformly dispersed inside a polymer matrix. Even a small amount of nanoparticles can significantly improve the properties. Examples include carbon nanotubes, graphene, nanoclay, etc. Then the second one is polymer nanofibers. These are the polymer nanofibers are extremely thin fibers produced mainly by electrospinning, where a high voltage draws polymer solution into thin fibers. Examples include um, polyvinyl alcohol, vinyl nitrol, etc. Then the third one is block copolymers. Block copolymers consist of two or more chemically different polymer blocks joined together. Due to incompatibility, they self-assemble into nanoscale patterns. Examples like cylinders, spheres, etc. And the fourth one is polymer nanoparticles. Polymer nanoparticles are solid colloidal particles which can encapsulate drugs or bioactive molecules. Then coming to the nanogels, these nanogels are soft cross-linked polymer networks which swell in water. They are highly responsive to stimuli like temperature, pH, etc. These can be used in biosensors, gene delivery, cancer therapy, etc. Then coming to the layered polymer with thin films. These are the polymer layers deposited in nanometer thickness, often using techniques like layer by layer assembly, spin coating, dip coating, etc. Examples like solar cells, sensors, gas separation membranes, etc. Some of these are the types of nanostructured polymers. Now, what are fuel cells? Fuel cells are electrochemical devices that convert chemical energy of a fuel directly into the electrical energy without combustion. So, they continuously produce electricity as long as fuel and oxidant are supplied. Uh, in other words, we can say that a fuel cell is a device that generates electricity, heat and water by reacting a fuel with oxygen through an electrochemical process. Some of the key features of these fuel cells like they produce electricity through the chemical reactions, they use hydrogen or other fuels, mostly we will be using hydrogen, then they generate water and heat as byproducts. Then the fourth one is they operate continuously as long as the fuel is applied, as I have discussed earlier, and they are environmentally friendly as well as highly efficient. Now coming to the basic components of a fuel cell, there will be four basic components in these fuel cells. First one is anode. Anode is the electrode where the fuel is oxidized, which means it will loses electrons, and these electrons go through the external circuit and produce electricity. Here protons pass through the electrolyte toward the cathode. Then the second component is cathode. Cathode is where the oxygen is supplied through this, and here there will be happening the reduction will happens here. Then the oxygen combines with protons and electrons to form water, where water will be formed at the cathode. Then the third one is electrolyte. Electrolyte is a special material placed between the anode and cathode. You can see the picture here, in which there is mentioned as membrane, which is nothing but the electrolyte. Electrolyte also will be there. This conducts ions between anode and cathode. These electrolytes does not allow electrons to pass through. This electrolyte can be a polymer, membrane, liquid or solid material. As you can see here, this membrane is nothing but the electrolyte. Then the fourth one is external circuit. The external circuit is the pathway connecting the anode to the cathode. Electrons released at the anode cannot pass through the electrolyte as they block the electrons. So they flow through the external circuit instead, which will generate the electrical current. So what is the role of polymers in fuel cells? Polymers are essential materials in fuel cells which will be mainly used in the membrane and electrode layers and play a key role in determining the fuel cell efficiency, durability and performance. They act as the electrolyte membrane. They enable in ion transportation. They provide mechanical strength to the substance, and they bind catalyst particles. They also control the water balance, which have a high ionic conductivity, high chemical stability, and they also improve the durability and efficiency. Now coming to the applications of nanostructured polymers in fuel cells, the first application is polymer electrolyte membranes, which in short form is PEM. So it is the most important application of nanostructured polymers in the fuel cells. What is happening in a fuel cell? So in a fuel cell, hydrogen is oxidized at the anode and produce protons, which are H plus ions, and electrons. So electrons move through an external circuit through which electric current will be conducted, and protons must pass through a membrane to reach the cathode. As you can see through the figure here, electrons will be passing from the above, which is external circuit, and protons, which are H plus ions, are passing through the electrolyte, which is nothing but the membrane. Then what is the role of nanostructured polymers here? Nanostructured polymers are used to make the polymer electrolyte membrane. These polymers contain nano-sized channels or domains that selectively allow only protons to pass through. Why nanostructure is important in these fuel cells? So these nanochannels provide continuous pathways for proton movement. They prevent mixing of hydrogen and oxygen gases, and they also retain water at the nanoscale, which is essential for the proton conduction. Then the final outcome will be high proton conductivity, high fuel cell efficiency, and stable operation at the low temperatures. So nanostructured polymers contain nano-sized channels and clusters that create continuous proton conducting pathways. These nanochannels hold water molecules, which are essential for proton transport. Role of nanostructured polymers we have already discussed. So the second application is catalyst support in electrodes. Fuel cells require expensive catalysts like platinum to speed up the reactions. So these reactions occur on catalysts like platinum, which are very expensive. If catalyst particles agglomerate, the efficiency will be dropped. So nanostructured polymers act as support materials that hold the catalyst particles evenly, which increase the conductivity, whichever property. So what is the role of nanostructured polymers here? Nanostructured polymers act as support materials that hold the catalyst nanoparticles in its place. So how this process will continue? Let us see. The polymer has a large surface area due to nanoscale structure. So catalyst particles are evenly distributed over the surface. This maximizes the number of active reaction sites. As an outcome, we'll be getting high reaction rate, reduced platinum requirement, and improved power density. The benefits include more efficient hydrogen oxidation and oxygen reduction, and the uses of catalyst will be less, and these are the properties of the second application. The third application is gas diffusion layer enhancement. So fuel cells require controlled supply of hydrogen and oxygen to the catalyst layer. So nanostructured polymers modify gas diffusion layers by introducing nano-sized pores. Uh, the challenge is hydrogen and oxygen must reach reaction sites efficiently and produced water must be removed. So the role of nanostructured polymers here is they will be used in gas diffusion layers or coatings that control gas flow at the nanoscale, and these pores will be regulating the gas flow, prevent uneven distribution, and assist in removing the excess water. The role of nanostructured polymers here is nanopores will allow uniform gas distribution. They balance access and water removal. They control the water movement to avoid flooding. The impact will be enhanced reaction efficiency, stable fuel performance, and higher power density. And the fourth application is water management control. Water is both necessary and problematic in fuel cells. If it is too less, it will dry the membrane, and if it is too much, it will cause flooding. So nanostructured polymers have hydrophilic and hydrophobic domains at the nanoscale. What these domains will do? They will absorb water when it is dried, and they will release excess water when it is flooded. So this will maintain the optimal hydration in the membrane. What is the importance of this nanostructured polymers here? This increases the fuel cell lifetime and improves the continuous operation. So the mechanism in this process will include nanodomains trap water molecules. As I have discussed, if it is water is too less, that they will absorb the water molecules, and if water is excess, that will remove the excess water. Then coming to the benefits, it prevents membrane drying and avoids electrode flooding, which improves the long-term durability. The fifth application is durability and chemical stability enhancement. So the main problem here is fuel cell components degrade due to heat, mechanical stress, and chemical attack. The role of nanostructured polymers here is they provide reinforced structures that resist degradation. Why nanostructure helps in this process? This nanostructure helps to distribute mechanical stress uniformly, which reduces the formation of cracks and enhances resistance to oxidative damage. Other than the applications of nanostructure polymers in fuel cells, there are wide range of applications of these nanostructured polymers, which include drug delivery, bioimaging, in automobile industries, in textile industries, and in packaging also. If we say in packaging, these nanostructured polymers will reduce the microbial growth, which helps the food to not to spoil within the shorter period. And also in textile industry, if we say, these nanostructured polymers helps the cloths to be wrinkle free, resistant, free fire resistant, etc. So these are the wide range of applications. Now coming to the applications and limitations of nanostructured polymers, let's discuss the advantages. Advantages include improved mechanical strength. These nanostructured polymers are lightweight materials. They have large surface area. They have enhanced electrical properties and controlled functional properties, multifunctionality, and they have very longer service life. Coming to the limitations, these are very complex and manufacturing process and high cost of production. Mainly people who are working with nanotechnology are health affected, and this will cause many environmental concerns also. And it will also causes difficulty in recycling, which causes regulatory challenges. This ends my presentation. Thank you.